Thank you. I like to touch one topic that has been discussed in the last day, but put more attention to the topic of startups and how startups can be a huge value in innovating in the semiconductor industry. Today, if you look at, especially in Europe, we have spent a lot of money on supporting established semiconductor players, but also on the established large RT organizations. I miss a bit more the startup scale-up part. I like to focus on that in the coming few slides. And as you can see, this is a bit of a summary of where we have been talking the last day. In fact, it summarizes the situation we are, where the technology is spreading. So we have, of course, on the one side, the mainstream CMOS technology, which keeps going on more and more, but also alternative technologies. Starting, of course, with more and more, but also especially photonics, which is on the verge to become a market. You have already photonics in data centers, followed by neuromorphic as well as quantum technologies. As a matter of fact, in Europe, we have excellent startups in all these different segments, both on the chip design, as well on chip manufacturing, as well as on equipment. And we need to help them succeeding. I'm personally quite involved as a business angel and also sit as advisor in 6 or 7 of these startups across Europe. And I always hear the same story. We need your help to get, to scale up, to mature, and become really a company. And I'd like to elaborate on that. This is showing you the investments in deep tech. There's also including, for instance, batteries in this place. But to the left side, you see chips, you see materials, photonics, quantum. This is taken from the US, but I think it's quite representative for what is happening in the VC scene. So private investors, venture capital, of course, like more to invest in design companies because they resemble more the fintechs of the world. So it's easier to put money in a chip design company than doing this into a hardware company, because hardware company needs longer, it's more complicated, you need capex. And this is creating issues because it creates a bit of an imbalance in the value chain. I colored here, this is my own opinion, the different parts of the value chain and how it could end up in being unbalanced. And we were talking yesterday a lot, debating about design versus factories or both. As a matter of fact, if you look at the pipeline that is going on in from venture capital and also funding, the majority is going to the left side, to the RTOs, and also IC companies, and to some degree to startups. And that could create in 5 years more imbalance on the right side, which is, in my view, a very important one. So the factories, the supply chain, and not only for the existing players, we need new players in manufacturing across the world, in Europe as well, especially for those technologies that we were showing. It's, in fact, a unique time in history. I've been also 30 years in the industry. And you see this diversification is opening opportunities. It's not anymore who is going to do the 2 nanometers, but also who is going to make the first neuromorphic computing chip that works perfectly, or the first superconducting or photonic quantum computing chip that is the best in the world. So you have opportunities to now differentiate as a new player, and we need to also take care of that. So this is an example of a quite well-balanced ecosystem. And everybody knows that. This is China. In fact, during my time at ASML, I spent many years flying into China, starting in 2015 when they came out with their 5-year program, which they have extended a few times. And you will laugh, but some of these companies are really startups. Many of them, take CSMT, YMTC, but many others, which were just set up because there was a long-term strategy. And the Chinese executed among this. And I'm not saying we have to copy this. But this is an example of an ecosystem which has been built mainly over the last 10, 15 years. And it is possible. Of course, you need massive commitment, a clear strategy, aligned strategy, and then go and execute. So this is a good example of that these things are possible. So if you look into deep tech startups, they are different. They need longer to make a mature product. They're more complex. There's a lot of R&D focus still, so the change from R&D into volume, into a manufacturing, into a product that is stable is more difficult, and they are not very sexy or attractive for many venture capitalists. I would say in Europe we have also a problem that the venture capital funds are relatively small as compared to the US. In US you may see some big investments in startups, also in the hardware space. Just recently in the lithography space there were 2 of them. But we need this also here. That's also a dilemma, how to deal with that. There is a way to help them. It's basically by combining private and public investments, activities, to help those companies scaling up. And this describes very well the dilemma of a startup. They have at least 2 levels of that. In a sense, at the beginning, they get started from the university, and they want to first build a prototype, a demonstrator, and a university lab, typically. And this is well organized. Typically, they manage this. There are VCs, early-stage VCs, which are supporting these kind of transitions. But the real problem comes later, which is this scale-up well of death, which is the one that most of them are struggling with. And as a fact, I'm sitting in some boards of these companies, and they are coming with the same question. How the hell are we going to manage to become a real commercial company? There are different ways out of that. One is to move to the US. Sometimes they made it. To get acquired before the Series B, because that's what is maybe solution. But there is a better solution to that. And this is what I would like to show you. If you look into the analysis of these companies, they are not just needing money. They especially, I'm talking about hardware, equipment, chip, but also software could be used here. They need also partnerships. They need clients, they need an ecosystem, they need infrastructures to execute this maturation of the technology. And at the end of the day, at the end of this path, there will be, hopefully, their own fab. This will take time. And in order to get there, in order to solve the dilemma, we need a new product, and I have to demonstrate this before I get money. We need to put infrastructure in place, which helps them maturing the technology in a real industrial environment. And this is what we call pilot lines. And I will show you later one example, which is something where I'm deeply involved in Barcelona called InnoFab, which is exactly meant to do that. And the idea is once you have done the maturation and you have a prototype which is run on industrial equipment that can be transferred one-to-one to a foundry, that's the moment you are prepared to then go to foundries or to really build your own foundry. And this is the example I was just mentioned. This is something we are currently in the advanced planning phase. It's called InnoFab. It's going to be built in Barcelona, in Cerdanyola, near to the synchrotron. It's a 400 million project. It's a 200 millimeter pilot line for advanced or beyond CMOS technologies. And what is very interesting is the left bottom side, the clean room design is going to be perfectly suited for startups. We are going to create an incubator where we give them place to put their own equipment if they want, or have their technology IP protected. We will have a low TRL area, so industrial lab, and then we will have a high TRL pilot line. And we are going to help them maturing the technology and eventually going to the right side out of the InnoFab pilot line. So with that, I would like to stop my presentation just on time, and then give you